Eric has been into this type of research since he's about 6 years old. Was in the Navy doing communication stuff. He's very extensive background. He had free reign of the RCA facility in Bolinas when he was high school age, and he was actually doing some Tesla-style work before he even knew that Tesla existed. Many people around the world consider Eric the modern-day Tesla, who knows more about the nature of electricity than any human being alive. And he is literally rewriting the full science of the art of electricity as it was meant to be before it was derailed by a bunch of nonsense, and that is the subject of a lot of the books and videos that have come out over the years. So anyway, this presentation will be the history, theory, and practice of the four-phase system, Tesla's original system that there's very little information about. This will be the definitive presentation on the topic. Please welcome Eric Dollard.
So everyone's familiar with three-phase, but four-phase, I think, would probably leave a blank in most people's heads. Polyphase mathematics is its own obscure branch of mathematics that academia and mathematicians will not touch with a 10-foot pole. So that would kind of indicate that it must be worth looking into. The person that developed this mathematics applied it to three-phase, but nobody has ever applied it to four-phase. And a lot of interesting cans of worms open up into the application of that mathematics that has caused me to get even deeper into it to try to resolve. So basically, what I'm doing here in the first part, there's basically so much anti-Tesla and Tesla disinformation and what have you going on that I figured the best thing to do was to, at a practical level, define what Tesla really did with four-phase and why it was the way it was and why we would not do that today. But towards the end, I'm going to show that with the wild phase form of three-phase distribution, which is what this building is fed with, along with most other small commercial buildings, is because there's four conductors coming in the building that it's intrinsically four-phase, and it's actually quite easy to convert from the three-phase to the four-phase, and the four-phase has a lot of distinct advantages. And I'm probably the only person that's ever, when building some kind of maritime vessel, to use four-phase, and this presentation will show us why I did that. Okay, so let's start with Nikola Tesla. So the engineering achievements of Nikola Tesla. This is turning into a small book, but we couldn't get it done in time. But this is basically the booklet that I'm going to start with. So the system of polyphase power, which is the subject of the following text, was conceived in the latter part of the 19th century by Nikola Tesla. So here's where the polyphase starts. There was a very influential philosopher named Goethe. This gives his era here. He was in the basically the Mozart era, and a not well-known philosopher today, German philosopher, but in his time he was foremost. Throughout much of Nikola Tesla's life, he would be plagued by severe hallucinogenic episodes. Despite this condition, Tesla would learn to master it and put it to work for him. Accordingly, this provided him with an enhanced power of visualization. The mind of Tesla had been overly occupied with the ideas relating to AC rotating machinery, most notably the AC motor, the lacking element in the electrical utility system of his day. Historically, Nikola Tesla would claim his revelation of the rotating magnetic field and its polyphase system, which came to him in the form of an all-encompassing vision, or by his count, a flash of light. As the sun was setting, Nikola Tesla was reciting from memory certain verses written by Johann Goethe. The glow retreats, done is the day of toil, it yonder hastes, new fields of life exploring. Ah, that no wing can lift me from the soil, upon its track to follow, soaring. And this is what triggered Tesla off. At this moment, the vision in Nikola Tesla's mind was the sun acting as a whirling magnetic pole, carrying him around the Earth to follow soaring. Hence, the rotating magnetic field is born. The moment the sun set, the moment the sun was setting at Nikola Tesla's location, it was, at the exact same moment, at its noon position, 1/4 turn around the Earth ahead of him. At the same moment, the sun was at its sunrise position, 2/4 turns around the Earth ahead of him. Likewise, at this same moment in time, the sun was at its midnight position, 3/4 turns around the Earth. And finally, at the same moment in time, 4/4 turns around the Earth is the location of Nikola Tesla at sunset. The cycle is complete, consisting of 4 phases. This is where the 4-phase idea begins. In the mind of Tesla, the 4 unit phases hereby, the 4 unit positions of the sun are 1 for midnight, the start position, 2 for sunset, the first position, 3 for noon, the second position, and sunrise, the third position, and this will be the arch form that we'll build the polyphase mathematics upon. The wheel work of nature was a phrase used by Tesla. Everyone is very familiar with the phrase of attaching your mechanism to the wheel work of nature. So it's a 4-phase architecture that we're dealing with here. It goes back to ancient, very ancient times. It's a very important arch form called the solar cross. I don't know exactly all the details of that, but evidently this image is in all cultures in one form or other, particularly that of the Native Americans, which seem to have really focused on it. So this gives us our midnight, our sunrise, our noon, and sunset, and the degrees of rotation and the numbers that we're going to assign to these degrees of rotation and the phases that we're going to affix to these degrees of rotation. That's what we want. In the analysis of polyphase systems, several orders of coordinate sequences present themselves. The number of these sequences is directly related to the number of phases. So the positive sequence goes 0, 1, 2, 3. Negative sequence goes 0, 3, 2, 1, and then so on for the following phases. So it's just incremented one step ahead or behind, depending upon what reference point you're looking at for each phase. And of course, it repeats itself after phase D. You're back at phase A. Now, we can take the positive sequence and negative sequence, and we can make a composite out of them, a quadrature composite, which is shown on the bottom there, where the sequences start to interact with each other. The foremost are the positive sequence and the negative sequence, the two most fundamental sequences of any polyphase system. For a 4-phase condition, these sequences are portrayed by figure 7, and I believe it's figure 7. The interaction of the positive sequence and negative sequences will engender other less obvious sequences. Now here where we start to get into the meat of the matter. It took Fortescue to solve. This is an objective in the application of the Fortescue method. These other sequences can be arrived at by forming a composite sequence pattern, which I showed for the 4-phase condition, is shown in figure 7. So that's what's on the bottom there. So in doing that, let's see. What's my place? In the 4-phase composite configuration shown, the positive sequence is positioned horizontal and the negative sequence is positioned vertical. This results in a 4x4 square or lattice of 4-phase coordinates. In the constant current, there's no transformers because the whole thing operates at high voltage, even though in later time they did put in transformers because the voltages were so dangerous that any contact with the luminary device while it was on could be lethal. So they did start, some systems did start breaking up. Most of this started disappearing off the utility poles in 1958. You can still see little scraps of it around, but the last use of this is airport lighting systems where they hook all the incandescent lamps in series, and that may even be gone now. I will have no more text I'll read at this point. I'll just kind of talk about stuff. So this is one of the alternators, a cross section. These were 5,000 kilowatt machines, 2,200 volts, and they operated at 25 cycles per second. This is the rotor, which provides the excitation field for generating the power in the stator windings. This is an enclosed unit. This is the final extension of the power plant. After Tesla and Westinghouse proved that it worked, then they extended it all the way out to 10 alternators. You can see the switchboard standing in the kind of mezzanine in the middle. I had a lot more pictures of this in one of my prior presentations, but I didn't want to get into that kind of complexity. Plus, the copyright on all this stuff is they can't let this stuff go to the public. They got to keep their little claws on it. So I don't know if we can even use any of these pictures in the book. What you're looking at right now is a book that Griffin and I are working on finishing. That's why, you see the figures and references and all, because it's a book. Okay, now it's going to get thick, real thick. Okay, so 1 + 1 = 2. Everybody can handle that. So let's say 1 + 1 = 2. So we have a ship, and it's in west, and it's moving east, and it goes one step, or one distance, one span, and then it goes that span again, and it has moved 2 units to the east. That's common addition. But alternating current addition takes on this type of form, where 1 + 1 = the square root of 2. That could rightfully be called Pythagorean addition. So basically, if we've, at a starting point, sail to the north, and then sail this distance to the east, then that gives us this coordinate, and this is basically the Cartesian coordinate system. That is how navigation came about, was the Cartesian coordinate system allowed a way to express a position somewhere on the surface of the Earth. And in this case, we're just dealing with more of a circular function type thing. So now we can do the same thing where 1 + 1 = the inverse of square root of 2, which is this case here, where if we go 1 mile north, and then in this form we go 1 mile this way, then we end up here. So now we haven't gained any ground at all, really. We could have just gone straight. And you can see in this case, too, that this distance here is much less than adding these 2 distances together. And then finally, then we can, in opposition, travel 1 mile to the north, and then turn around and drive, or sail in this case, 1 mile back in the other direction. Then 1 + 1 = 0. So now how are we going to do this? And that's kind of the next stage here, because when you're dealing with alternating current and polyphase conditions, this gets really thick. So the other thing is, is the mesh and star. So most electrical engineers know in network analysis you have mesh and star configurations. So the mesh system tends to be a closed system. As you can see, it encloses a boundary, where the star system is an open system. And what's interesting is it takes a little meditation, which we don't have time now, but if you kind of meditate on this, you'll start to see the interesting complementary symmetry relationships between mesh and star, or in this case, what we refer to as delta and Y. In order to portray a mesh versus star coordinate situation for 3-phase, we have to have 12 coordinates. So basically, the standard clock face is an analog operational device for basically 3-phase power. It requires 12 coordinates. As we can see, some of these coordinates aren't used, so there appears to be kind of an imbalance also that comes with the 3-phase. And most importantly, it will be noted as we go from the star configuration to the mesh configuration that phase A has fallen behind 90 degrees, but the currents are the same. So the current has no choice but to be the same, because they're in a series connection, but the voltage doubles. So we have that type of complex addition going on here. But so the voltage, where this is a phase and this is the line, the voltage doubles, but the current remains the same in this configuration. Okay, now this is the common household system. This is the Edison system. Very few countries in the world total use the Edison system. It seems like most of the utilities around the world have defied Edison and Tesla with 50 cycles and an unbalanced 220, which is lethal. But this is what we use here, which is sensible. So we have, this is our neutral. So this is the black wire, this is the white wire, and this is the red wire. This is what comes into your house. You know, you got hot, neutral. It's 120, 120, and then around the outside is 240. So we want to connect this to four-phase because that's the particular advantage of the Tesla four-phase system, is this becomes a natural leg of it without a lot of power factor and phase goofiness. So here now we've connected two Edison systems to a Tesla system. So from the T, simply by moving where we put the voltmeter, now we have, which is a star configuration, we now have a three-phase mesh configuration, and this is how this transformation comes about. This kind of breaks it down a little more. It's very difficult to come up with a graphical presentation of this that makes any sense. I struggled with it for a lot to try to make this one image. It appears to be geometrically impossible. Maybe Pythagoras could do it, but I couldn't. But what we're doing now is we're developing the star current configurations that are intrinsic with a mesh supply of potential. I experienced doing electrical work in San Francisco is the three-story Victorian buildings all had elevators. The elevators were three-phase, 240 volts. Then they had Edison system, which actually was originally DC. The wire was run through gas pipes as conduit when the gas companies went out of business, and then the 125, 250 DC came in, which you could still buy in San Francisco, by the way, when I was there. PG&E still gave you 120, 240 DC if you wanted it. And so here I'm working on this house, and the guy's got the elevator, and it's on 1 meter and one panel. And then there's the house wiring, which is on another meter and another panel. And I found by taking the neutral of one and putting it, I forgot how I did this, but somehow I crossed the wires in the boxes, and the electric consumption meter, the indication on it was 86.6% of the actual power consumed. And the owner of the house was very fond of that idea. Phase B is the same situation, so we have zero sequence current for phase B, positive, alternate, negative. C, we have zero sequence, positive, alternate, negative, and for phase D, we have zero, positive, alternate, and negative. Okay, so this is what we have to work with. Now, what do these things mean, and how do we derive them analytically from our line currents? Because those we can measure with the meter. These things are mathematical abstractions and require a very specific network to turn them into something that will make a meter move, but it is possible by using sets of transformers and capacitors and what have you.